Hi everyone and welcome to this brass tacks video introducing gravity. Let's start with a definition. Gravity is an attractive force acting between any two bodies of mass. We have an equation for gravity. F equals G m1 m2 over r squared. Capital G is a gravitational constant, 6.67 by 10 to the negative 11 newtons meters squared per kilogram squared. This constant is the same throughout the universe. M1 and M2 are the masses of the two bodies that we're interested in. R is the distance between their centres of mass, in metres. Mass is always in kilograms, distance is always in metres. Let's look at a sample problem. Calculate the force of gravity acting between two 5 kilogram dumbbells placed 2 metres apart. This is a question you might find in a topic test or an exam. So first of all, what's the important information in this question? The two dumbbells have masses of 5 kilograms and they are 2 metres apart. It's always a good practice to try and underline or highlight the important piece of information. We'll need to know the gravitational constant, 6.67 by 10 to the negative 11. You don't need to remember that. It'll be in the formula and data sheet, so don't worry about that. We'll need to know the mass of the first body, the mass of the second body, and the distances between them. We select our equation, plug in our values, and we use our scientific calculator to very carefully find an answer. That answer is incredibly small, 4.17 by 10 to the negative 10 newtons. This is not a force that we're going to be able to perceive here on the surface of the Earth. It might make a difference out there in deep space, but not something we're too worried about here, an insignificant force. So when is gravity a significant force? Well, when we think about gravity, we think about our weight, the force of gravity pulling us down to the centre of the Earth. When we start thinking about the gravity due to the Earth, we just change the equation slightly to be capital G, capital M, m over r squared. In this restating of the equation, capital M is the mass of the Earth, lowercase m is the mass of us, or the object that we're interested in, and r is the distance between the centre of the Earth and between the object. If the object's on the centre of the Earth, then the distance is basically the radius of the Earth. Here's a sample problem. Calculate the force of gravity acting on an 88 kilogram science teacher standing on the surface of the Earth. So what's the important piece of information here? The teacher is 88 kilograms and the teacher is on the surface of the Earth. So let's think, what do we know? We know the gravitational constant. That's going to be in the formula and data sheet. We know the mass of the Earth. Now, you might think you don't know the mass of the Earth, but it'll be in the formula and data sheet. In physics tests and physics exams, we always make sure that you've got the constants that you need to have. There's the mass of the teacher. The radius between the centre of the Earth and the centre of the teacher is basically going to be the radius of the Earth. If you don't know the radius of the Earth, again, it's in the formula and data sheet, so you're going to be fine. We select our equation. We plug in our values. We very carefully use our scientific calculator to find a result, and we see that it is 863.6 newtons. Down. Force is a vector. It's pulling me down towards the centre of the Earth. Remember that number for later. Now, there must be an easier way for me to calculate my weight, and you might remember from year 7 when you did forces, and we told you that weight was a non-contact force, and we gave you an equation. We said that F equals mg to find the weight force of a person. We also told you that in year 10. So how does this equation and this strategy compare to that equation, F equals mg? When we look at these two equations side by side, we see that they have some common factors. Well, there's the big capital F there, and then there's the lowercase m. They are the same things. So it leaves us to ask the question, what exactly is lowercase g? Lowercase g is a summary of capital G, capital M over r squared. If you plug in the values capital G, capital M, and then divide them by r squared, the radius of the Earth, you're going to get little g. Little g is equal to 9.8 newtons per kilogram, and very often we also say 9.8 metres per second per second. When you plug in the values for capital G, capital M, and r squared, you're going to find that little g is 9.813 newtons per kilogram. Now, this is a little bit different to what you'll find in your formula and data sheet, which says that little g is 9.8. When you're doing tests and exams, you are free to use 9.8. It won't give you exactly the same value as 9.813, but then the actual value isn't 9.813 anyway. It's something even more decimal places. So, taking this strategy, F equals mg, to find the weight force of the science teacher, if we use 9.8, we end up with the science teacher's weight force is 862.4 newtons. If we use 9.813, then we find that the science teacher's weight is the same as what we calculated before, 863.6 newtons. In high school, in years 10, 11 and 12, a few decimal places between friends is not too much of an issue. You should always use little g equal to 9.8 if that's what's given to you in the formula and data sheet. Okay, that's the end for this brass tacks. I hope it was useful. I'll catch you next time.